Hi, my name is David, and today we're going to do number 11, container with most water on LeetCode. And we're going to solve this problem in JavaScript. So this question wants us to create a function, and we're giving the height, and it wants us to return the maximum amount of water a container can store, or the maximum area. And this is kind of confusing at first, but it wants us to find the maximum area, and we know that the formula for area is length times width. So if we look at this example here, we see here that 1, 1, 8, 8. The height is in these is the values in this array, and then the positioning on the bottom is the index value. So we calculate. Let's first look at the height. So this is the one in red is the most height. So we look at this one and look at this one, and this is the lowest. So we take the lowest of the two height. So in this case, it will be 7. It's the lowest between 8 and 7. And then we find the width of it, or the distance between the index values. So this is 7 index values difference. So this is at index 1, and this is at 0, 1, 2, 3, 4, 5, 6, 7, 8. Index 8, 8 minus 1 is 7. So we do 7 times 7 is 49. And that's the maximum. If you were to compare with each pair and compare it, 49 will be the maximum, and that is what we return. So one way you can solve this is that you can do a nested for loop and look at one and then calculate the area for each one of them and compare it with the current maximum area, and replace it. But there's a clever way of solving this problem, and that'll be using 2 pointers. The idea here is that we start a pointer on the left, all the way to the left, and all the way to the right. The reason for that is that the formula for area is length times width, and this will optimizing the width because it can't not be bigger than the 2 indexes in far end for the width. So, but the height can still change. So what we do is that we create a pointer at each one, and then the lowest pointer, we know that this is the maximum width, but we can have a different height that can vary. So we can increment the pointings accordingly. So whichever one has a lower pointer, we can increment up. So if this one has a lower, so we increment up to 8 here, and then we compare 8 to 7. Since this has a higher one, we go to the right side and increment down. So now we compare 8 and 3, and then we compare the area and with the maximum area. And since this is low, we go down, and then we compare 8 and 8, and then we can do a condition for something with equal on either side. So we can go to 6 to 8 and so forth. So let me write this down. So what you want to do is that the first step of this problem is that you want to create the pointers. Create left pointer and assign it to 0. And then next you do create right pointer and assign it to the height dot length -1. Great. So now we have the 2 pointers. What we can do now is find the max, create a maximum variable, and this is the variable we're going to hold what's currently the max area as we traverse through this array using pointers. And we can start off with the current area. So, and assign it to the current area with the starting. So we can first start it with 1 and 7. Find that area. And now we do a while loop while left pointer is less than right pointer. So we're going to keep traversing until they hit. And now inside of this loop, we got to compare. We can look at the left pointer first. So if the index value at left pointer is less than the index value at the right pointer, we increment left pointer. Else we do else increment the right pointer, decrement the right pointer, I mean, because we have to do the opposite. And that will catch the equal then sign too. And then once we do that, we calculate the area and then take the max of current area and max area. Sorry, let me change this to max area. And lastly, just return max area. Great. So let's do this. Left pointer equals to 0. Let right pointer equals to height dot length minus 1. Great. Now we find the max. Let max area, and then I'm gonna state. Sorry, let me use a different variable for this. Calculated. Okay. And let's create a separate function for find area equals a function. And this is, and we're going to use this to calculate the length times width part and convert this so it's in a format we can do that. So we can take the left pointer, right pointer, and then the height. Great. So now let's calculate the width first. Width equals right pointer minus left pointer. And then we do the height, constant height. Instead of height, let's do length because we have height already. Equals height so we have the math.min height index at left pointer, height index at right pointer, and then the area is width times length, and this is what we return. So to explain this, we're starting at index of 0, and this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 8. So we do 8 minus 0, we get 8, and then we compare the height. So this is height of 1, this is height of 7, the minimum is 1, so 1 times 8 is 8, and that's what we return, and that's what the current area is. So we just pass that through. Great. So now we do the while loop. While left pointer is less than right pointer, we compare the height. So if height index left pointer is less than height bracket right pointer, we increment left pointer. Else we decrement right pointer. Great. And now we can call this function again, find area with the updated pointers. const current area. And now we update this max area calculator. Max area calcu. Sorry about the spelling. Equals math dot max current area max area calculated, and that's what we return. Sorry about that. There's no extra parentheses here. Great. So that's how you solve this problem. And then the time and space complexity. Since we're just doing a while loop here and using pointers, it's going to be O of n. And then the space complexity. Since this is a constant function and all of these are constants, we're not creating another hash table or anything. So it's going to be O of 1. Great. So that's how you solve this problem. Thank you so much.